All right, you guys. So let's go over how to do some parts of this worksheet that might be a little confusing. You can use your notes to answer the questions here. You could use your notes here and then answer this using the periodic table. I'm going to see if you're able to do that. What I want to go over is how to do this chart and how to do the thing on the back. Okay, so we're going to do the first one together. We're going to do the element carbon together. So the way you do this is you go down and you look at the elements. The first one is carbon, the second one is hydrogen, oxygen, nitrogen, phosphorus, and all the way down. What you want to do is go into your periodic table and look for the name. So carbon is right here, okay? Then hydrogen would be all the way over here, right? So look for each one. Carbon has a symbol. Remember, the letter here in the middle is the symbol. Sometimes the symbol is one letter, sometimes the symbol is two letters. It just depends on the element, okay? So carbon's symbol is C. We're going to write the letter C in here. Then we look for the atomic number. The atomic number is here in the corner, okay? Carbon's atomic number is 6, so we're going to go in and we're going to write the number 6 for atomic number. There's a paper under it messing me up. Okay. We're going to look for the atomic mass next. Let's fix that. So for carbon and for all of them, the atomic mass is the number down here at the bottom. Here it's 12.011, so we're going to write that here for atomic mass. 12.011. Okay. Now that's all the information we need for now from our periodic table. We know from the notes, hopefully, that the atomic number tells us how many protons we have. So since carbon's atomic number is 6, it has 6 protons. We also know that the number of protons should be the same as the number of electrons. So there's, oopsie. I don't know why I did that. There's 6, okay? Now, the next thing we have to do is ask ourselves, how many valence electrons do they have? And there's a place to look to find it. So at the top of each column, you will see a number followed by A or B, okay? So here's 3A, here's 4A, here's 5A, and so on. Carbon is 4A. That number 4 tells us that there are 4 valence electrons. Okay? Then we have to ask ourselves, how many bonds can carbon make? Well, here is a rule. You can write this down. If there are 1, 2, 3, or 4 valence electrons, I'm going to write VE for valence electrons, then the number of bonds is equal to the number of valence electrons. Okay, so that's the first part of the rule. If there are 1, 2, 3, or 4 valence electrons, the number of bonds is equal. So because carbon has 4, it's going to have 4 bonds. Okay, now what if there's more? Because for example, here, oxygen has 6, right? 6A. Fluorine is going to have 7. Sulfur has 6 as well. So there's a lot of different ones. So if there are 5, 6, or 7 valence electrons, then the number of bonds is equal to 8 minus the valence electrons. Okay, so going back to our example, if I'm looking at fluorine that has 7 valence electrons, then 8 minus 7 is equal to 1 bond. It can make 1 bond. Okay? Now, what happens if there are 8 valence electrons? That is our third rule. If there are 8, then it will make 0 bonds, because 8 is a magic number. Okay, 8 and 0 really, but 8 is the magic number that all of these atoms want to get to because it makes everything stable. Okay, so again, if you have 1, 2, 3, or 4 valence electrons, then the number of bonds is equal to the number of valence electrons. If you have 5, 6, or 7, then the number of bonds is 8 minus however many valence electrons. So 8 minus 5 is 3, 8 minus 6 is 2, 8 minus 7 is 1. But if there's 8, then you have no bonds. Okay, so that's how you're going to figure out this table. Now on the back, it tells you to draw the Lewis dot diagram, which is super easy to do. Okay, you're going to, well, let me show you how to do it down here first. You're going to write the symbol in the middle, whatever that symbol is, right? So for example, C for carbon, N for nitrogen, B for boron, Al for aluminum, Si for silicon, things like that. You write the symbol in the middle. Then you're going to make dots. You start at the top. This is your first dot. Okay. Then you go to the bottom as your second dot, kind of like you're doing a cross. Third dot, fourth dot, and then you start at the top again. Fifth dot, sixth dot, seventh dot, and eighth dot. See how 8 is a magic number? They all want to get to 8, okay? And then the dots are valence electrons. Okay? So let's do one that you don't have on your list. Let us look at bromine, okay? Bromine is going to have 7 valence electrons, okay? So if I follow what I did here, I am going to do Br for bromine, and bromine has 7 valence electrons, okay? So the first valence electron goes there, second one, third one, fourth one, 1, 2, 3, 4, like you're making a cross. Fifth one, sixth one, seventh one. So 1, 2, 3, 4, 5, 6, 7. That would be the dot diagram for bromine. Okay. Let's do this one more time. Let's do carbon together. Carbon symbol is C. And if we remember, carbon has 4 valence electrons. Okay, I'm just writing that 4 to remind myself there's 4. So we start at the top. 1, 2, 3, and 4. So that's the dot diagram for carbon. You can see that these 4 valence electrons, they are not paired up. They don't have a friend. Remember in the notes, I said that valence electrons like to have friends. They don't want to be alone. So these guys want to pair up, which is why carbon can make 1, 2, 3, 4 bonds. Okay. Well, what happens, Miss Vo, if you don't have enough electrons? That's fine. You just stop wherever you finish. Okay. Just like we did with bromine. We don't have all 8, so we went 1, 2, 3, 4, 5, 6, 7. you can see that bromine has one little electron here all by itself. So bromine, if it wants to, it can make one bond. Okay? I hope that makes sense. Email me if you have questions.